Hello, let's talk about Java on the IBM Cloud. After you complete this unit, you should understand the IBM Cloud platform, understand Cloud Foundry and Bluemix architecture. You should be able to compare the Java and Liberty build packs running on the IBM Bluemix platform, as well as understand the tooling to develop and deploy Java applications on the cloud. Bluemix is IBM's cloud platform built on top of open source Cloud Foundry paths, where you can compose applications quickly using the APIs for various cloud services, thus avoiding tedious backend configurations. Bluemix offers services in the following categories: DevOps, Big Data, Mobile, Watson Cognitive Services, SQL and NoSQL databases, Business Analytics, Web and Application Development, as well as Security, Internet of Things, and very importantly, Hybrid Cloud Integration. Bluemix enables cloud deployments that fit your needs, whether you are a small business that plans to scale or a large enterprise that requires additional isolation. You can definitely develop in a cloud. You can connect to your on-premises services using the secure gateway client provided on Bluemix, as well as bind to the services which are available from IBM and many third-party providers on IBM Bluemix. Therefore, you will see a range of services that enable you to build and extend web and mobile apps. You will see that you can manage your services and apps easily using the cloud, as well as have an optimized and elastic workload. There are three flavors of running Bluemix. One is the public Bluemix Cloud. The other is dedicated Bluemix that offers you a private cloud on an IBM Cloud data center, using which you can keep the data close to your location within country boundaries as desired. The third flavor is local Bluemix that offers private cloud on your own data center. Next, we should look at how you can run your code. Bluemix offers Cloud Foundry runtimes. It offers IBM containers and OpenStack VMs. Using the runtimes, you can develop and manage your application code and leave the management and maintenance of the infrastructure to Bluemix, along with the maintenance of the middleware, since Bluemix is a PaaS. Now with IBM containers, you can run your web app anywhere that supports container deployment. As you know, container is an object that holds everything that is needed for your app to run. This infrastructure includes a private registry for your images so that you can upload, store, and retrieve them. You can make those images available in Bluemix and manage your containers in the platform. The IBM containers infrastructure will scale horizontally as well as vertically. You can use all of the images that are available in the public Docker Hub and use the Docker API and command line to manage your containers on Bluemix. We are also providing some public images in the containers registry that you can use and extend. So essentially, IBM containers are used to run Docker containers in a hosted cloud environment. Now, the virtual machines infrastructure gives you the ability to create and manage virtual machine groups on the IBM public cloud. You can also create and manage VM groups on your private clouds. So this way you have more control on the OS and middleware if you so need. You can deploy and manage your virtual machines by using the Bluemix user interface or the OpenStack APIs. Virtual machines on Bluemix support provisioning of virtual machine groups with auto-scaling. So auto-scaling is a neat feature that gives you the ease of maintaining your apps as per the load requirements on your applications, and it also manages your resources efficiently. We also support load balancing, so we can assign virtual IP addresses as needed. Let's look at the Cloud Foundry and Bluemix platform architecture. As you can see, we have multiple layers of security and load balancing built into Bluemix using the Data Power appliance. When a user logs in, the request goes through the firewall and Data Power appliance to the router. The router in turn sends the request to the OAuth 2 server and the login server to authenticate the user. Similarly, while provisioning a service instance on the cloud and executing DevOps on an application running in the cloud, the request goes through the firewall and the Data Power appliance to the router. The router then routes the request through the Cloud Foundry control elements, through the Droplet execution agent, and through the service gateway to the service instance on the cloud. So let us walk through the Cloud Foundry control elements. These include a cloud controller, the health manager, Droplet execution agent, the service broker, blob store, the message bus, and log aggregator. So diving a little deeper into these elements, the cloud controller is going to store the raw application bits, create a record to track the application metadata, and direct a Droplet execution agent node to stage and run the app. The cloud controller will also maintain record of your organizations, spaces on the cloud, your services, and also your user roles. Next, the health manager will monitor your applications to determine their state, whether running or stopped or crashed. Also, the application version and number of instances running. The Droplet execution agent maintains application instances, tracks the started instances, and broadcasts the messages regarding the state of the application instances. Application instances live inside Warden containers. The containers ensure that the application instances are running in isolation and getting their fair share of resources on the cloud. The blob store will be holding the application code, the build packs used, and the droplets. Now, the service broker for a service is responsible for creating and binding to the service instance. We need the message bus to give us a lightweight messaging system for internal communication between the components. And a very important piece of the elements we have discussed is the log aggregator. So now the application log aggregator streams application logs to developers, as well as includes a metrics collector to gather metrics from the different components. So these are the different constituents of the Cloud Foundry and Bluemix architecture, let's go deeper into the cloud platform. We have brought a full set of developer services into Bluemix. You can bind your applications running on the cloud to any IBM or third-party or community-supported services. Let's say Watson, big data services, mobile services, and so on. You can also integrate the cloud apps with on-premise software systems using the secure gateway. If you need the flexibility of controlling the operating system and the middleware, then it would be better for you to deploy your applications on the IBM containers or OpenStack VMs as we discussed earlier. Next, we have a cloud marketplace to host partner applications, and this is our software as a service portal. Now let's look at the two build packs that you can bind to while running your Java applications on the IBM Cloud. You can use the Liberty build pack, where you will be running the applications on WebSphere Liberty Server on the cloud, or you can bind to the Java build pack, where you'll be running the applications on Tomcat application server. Let's compare the Liberty build pack with the Java build pack. Liberty build pack runs on WebSphere Liberty Server and supports full JEE 7 platform, whereas the Java build pack runs on Apache Tomcat 8 and supports certain select JEE 7 technologies, for example, Servlet 3.1, JSP 2.3, EL 3.0, WebSocket 1.1. Next, the Liberty build pack supports IBM JRE along with OpenJDK. The Java build pack only supports OpenJDK. Let's look at the packages that can be pushed to the build packs. You can push a WAR file, an EAR file, the entire server directory, or even the complete packaged server.xml to the Liberty build pack to customize your deployment, whereas only WAR file can be pushed to the Java build pack. Now, our applications come with a set of environment variables, come with the configurations. With the Liberty build pack, the Cloud Foundry environment variables, that is VCAP services, VCAP application, as well as the application config, can be converted into a server variables. So you will see the environment variables and application config variables part of the runtime vars XML file when you use the Liberty build pack. Whereas in Java build pack, you will have to fork it to customize the application configurations. The Liberty build pack also has a neat feature of auto-wiring services that are available in the catalog. So the auto-wiring is applicable to 14 services in the catalog, and we will talk about these services in the next session on consuming cloud services. The Java build pack only auto-wires 5 services. The Liberty build pack, as you can see, is fully supported by IBM. The Java build pack is community supported. We have better performance with the Liberty build pack with respect to application push time, the memory footprint for warm cache push, the runtime throughput, and the time to scale up application instances. A neat feature with the Liberty build pack is that you can turn on development mode and application debug mode using the IBM Bluemix Eclipse plugin, and then push incremental updates from Eclipse IDE to the app running on the cloud and debug them in the Eclipse IDE as well. So let's see further features of the two build packs. It is easier to customize the application server with the Liberty build pack, and to do so, you can push the package server XML to the Liberty runtime in the cloud. To customize the Tomcat application server, you will have to fork the Java build pack and make the necessary changes. Now, you may have noticed that there are times where files need to be bundled with the JDK in order to expose certain functionality in the JVM. And in such cases, you can include the overlay files in the application package and push the application to the cloud using the Liberty build pack. You cannot do that with the Java build pack. To do that with Java build pack, you'll have to again fork it and make the changes. I have seen that JVM options can be updated very easily, and the application just needs a restart with the Liberty build pack. With Java build pack, you'll have to push the entire application code again for a JVM option change. Let's look at the Bluemix Eclipse plugin that enables developers using Eclipse IDE to develop and build and debug, as well as deploy Java applications seamlessly to the cloud. IBM contributes to Eclipse and Web Tools platform. On top of this layer, Cloud Foundry has developed an open source CF framework using which IBM has built an Eclipse plugin that allows you many features for your app development and deployment. You can download this plugin from the Eclipse marketplace. As we discussed, IBM Eclipse tools are based on Cloud Foundry Eclipse tools. They allow developers to develop and push applications to the cloud directly from Eclipse IDE, and these tools support the Tier 1 runtimes, namely Liberty for Java and Node.js. The IBM Bluemix Eclipse plugin provides us several capabilities. It gives us ops tooling to maintain the server lifecycle. You can create the Bluemix server and connect to it. You can start the server, stop the server, restart, as well as remove the Bluemix server. The plugin also gives us tooling to maintain the applications. So using this plugin, you can deploy the apps as well as update them, restart the app, and remove the app as you need. The plugin gives us development tools to create service instances and bind the service instances to the applications. We can run the applications and remotely debug the applications. We have the capability using this tooling to tune the Bluemix server, edit application information, as well as the deployed application instance information in the Eclipse IDE. So you will find this tool, or these set of tools actually, very nifty, and we will share them with you in a lab in a later session. Let's just take a look at how you can enable the development mode as well as enable the application debug mode by simply right-clicking on the deployed app running on Bluemix server. So these modes will allow the developer to do remote debugging and push incremental updates. Earlier, you had to deploy the entire application for a simple change in the app. After enabling development mode, you can publish only the changed files to the Bluemix server, and changes will take place immediately without redeploying the entire application. After enabling application debug on the application deployed to Bluemix, you can debug the application in Eclipse just like you would debug a local application in the IDE. So in this session, you learned about IBM Bluemix Cloud Platform, the Cloud Foundry and Bluemix architecture. You compared the Liberty buildpack with Java buildpack, as well as looked at the IBM Bluemix Eclipse plugin that enables developers to develop, test, debug, and deploy applications to the cloud. I hope you enjoyed this session. Thank you.